Hello everyone, this is good morning. This is John Seda from section C section. Today's topic of the PNS is probability distribution function. Let us go into topics. Probability distribution function, probability distribution function formula, binomial probability distribution function, different types of probability distribution, discrete probability distribution, and Bernoulli trials and binomial distribution examples. Probability distribution function. Probability distribution indicates how probabilities are allocated over the distant values for an unexpected variable. A probability distribution function has various belongings like predicted values and variance, which can be calculated even when all the values of unexpected variable are aligned on the graph. Then the value of probability yields shape. In probability distribution, the result of an unexpected variable is constantly ensured. It is known as the process that maps the sample area into the real number area, which is known as the state area. However, here the result observation is known as actualization. Let us go to probability distribution function formula. The probability distribution function is essential to the probability density function. This function is extremely helpful because it appraises us of probability of an affair that will appear in a given intermission. Let us use the formula. P of a less than x less than b is equal to sigma a to b f of x dx is equal to sigma b to a 1 by sigma root 2 pi e power minus x minus mu in whole square d sigma square dx, where p x less than a less than x less than b is the probability that x will be in the interval ab in any instant time. For example, p of minus 1 and less than x plus 1 is equal to 0.3 means that there is a 30% chances that x will be between minus 1 and 1 for any measurement. Binomial probability distribution formula. Binomial distribution formula. It is defined as the probability that occurs when the event consists of n repeated trials and the outcomes of each trial may or may not occur. The formula for binomial probability is as stated below. PR out of n by RL into PR 1 minus P n minus R NCR plus NCR into PR of 1 minus P of n minus R, where n is equal to total number of events, T is equal to total number of successful events, P is equal to probability of success on a single trials, NCR is equal to n by R by n minus R. Like, it is defined as a probability that occurs when the event consists of n repeated trials and the outcomes of each trial may or may not occur. The formula for binomial property is as stated below. N is equal to total number of events, R is equal to total number of successful events, P is equal to probability of successful on single trials, NCR is equal to n by R by n minus R. Different types of probability distribution. Since now we have seen that probability distribution comprehended, as now we will see distinct types of probability distribution. A type of chance distribution is defined by the kind of unpredictable value. There are two types of probability distribution. Discrete probability for discrete variables. Probability thickness roles for continuous variables. Discrete probability distribution. Discrete distribution is a likelihood distribution that shows the happening of discrete individuals countable result such as 1, 2, 3 or 0 versus 1 point. The binomial distribution, for instance, is a discrete distribution that estimates the probability of a yes or no result happening over a given number of attempts given the effort's probability in each attempt, such as tossing a coin 200 times and holding the result by b tails. A discrete probability allocations relies on happening that includes countable or delimited result. This is a disparity to a constant allocation where result can drop anywhere on a continuum. A familiar instance of discrete allocation contain the binomial Poisson and Bernoulli allocations. These allocations usually involve statistical studies of calculation or how many times an affair happens. In finance, discrete allocations are used in choice pricing and forecasting market surprises or slumps. Bernoulli trials and binomial distribution. The Bernoulli trials is one of for which the probability the affairs happen is p and probability that affairs does not happening in 1 minus p. Either the affairs has two likely results usually regarded as win or lose, happening with probability p and 1 minus p respectively. A Bernoulli trials is an installation of Bernoulli affairs, so prolonged as the probability of win or loss stays exact from an attempt to attempt. Either each attempt is separated from the others. A series of Bernoulli trials is called a Bernoulli procedure. Among other findings that could be achieved, this indicates that for n attempts, the probability of an n wins is p power n. The Bernoulli distribution defines the win or loss of a single Bernoulli trials. The binomial distribution describes the numerical of wins and losses in n autonomous Bernoulli trials for someone given worth of n. For example, if a fabricated item is flooded with probability p, then the binomial distribution describes the numeral of wins and losses in bunch of n objects. In precise, a selection from this allocation gives a total of the numeral of dependent object in a representative lot. Another example is the number of trials acquired in tossing a coin n times. Binomial distribution. It is an unexpected variable that describes the number of wins in successive liberated trials of Bernoulli's investigation. It is utilized in an overload illustration like containing the number of heads in n coin flips and so on. If y is a binomial random variable, we indicate this is y being n minus p, where p is the chance of a win in a given trial, q is the probability of defect. Let n be the total number of trials and x be the number of wins. And binomial random variable has the subsequent properties. P of y is equal to ncx qn minus x px. Now the probability function p of y is known as probability function of the binomial distribution. It is an unexpected variable that describes the number of wins in n successive liberated trials of Bernoulli's investigation. It is utilized of an overload illustration like containing the number of heads in n coins, flips, and so on. If y is a binomial random variable, we indicate this y being n minus p, where p is the chance of winning in a given trial. Q is the possibility of defect. Let n be the total number of trials and x be the number of wins. By binomial random variable has subsequent properties. P of y is equal to ncx q power n minus x p of x. The probability function P of y is known as probability function of binomial distribution. Thank you.